Here we have a capacitor and it's charging via a current source. And we want to see the charging characteristics. The first thing I would want to do is to convert the current source into a voltage source so that we can find the initial voltage that the capacitor is charging to. So if you multiply the current times the resistance, you get 1 volt with a 1 kilo ohm resistance in series. And now, to see the initial voltage that this is charged to, you'll see you have an EMF in series with two resistances. The important thing to note is that a capacitor initially behaves as an open circuit, and in the longer term it behaves as an open circuit. So we can redraw this circuit, removing the capacitor, replacing it with an open circuit. So your capacitor is removed, your voltage source 1 volt, this is the 1 kilo ohm resistor that was in series with it, and this is your second resistor. So you can see that the capacitor is initially charged to 0.5 volts because the 1 volt is divided equally between these two equal resistances, or you can use a voltage divider, a potential divider. So we know that initially there's 0.5 volts across the capacitor, but as time passes the current reduces and the amount of the potential difference across the capacitor reduces until in the longer term it behaves as a short circuit in the sense that there is a zero potential across it. So as t approaches infinity, this potential reduces until it's almost zero. And the time constant is simply the product of the resistance times the capacitance. In this case, it's 3 milliseconds. So at 3 milliseconds, the voltage will have reduced to 1 over E multiplied by 0.5 volt. So that's how you would deal with a question like this. The important thing is to note that initially the capacitor behaves as an open circuit, and you can treat this as a normal DC circuit, and you can find this potential using Ohm's law or potential divider.